Sairam students, welcome back to the second session of chapter 8, that is static electricity. So before starting today's session, let's revise what we had learnt in the first session. So children, we had taken 3 examples which gives us the partial view or the glimpse of electric charge, right? So after that children, we discussed that the electric charge, it is present in large quantities, but it is always present in the hidden state. So why it is present in the hidden state? Because actually all the substances or objects, they are made up of very tiny particles, and electric charge, it is an intrinsic property of these particles. That means this electric charge, it is naturally it is a natural property which is present in these particles. So all the substances, they have equal number of electric charge, that is equal number of positive charge and negative charge. So they are balanced, right? So when they are balanced, that means there is no charge on the object. But when for some reason their balance is disturbed, so what happens? There is a charge on the object, right children? So after that children, we discussed about the 2 experiments, right? Taking a glass rod and a plastic rod. I hope you remember it. So what from the first experiment, what we concluded, that when 2 similar charges are brought near each other, so what happens? They push each other away, that is there is a repulsion. So 2 rods carrying similar charges, they push away each other, and that is called as repulsion. And in the second experiment, we had taken a plastic rod and a glass rod. So from that second experiment, what could we conclude? We concluded that the 2 rods, they carry opposite type of charges, and opposite type of charges means they attract each other, and this is called as attraction, right? And scientist Benjamin Franklin, he named this electric charge as positive charge and negative charge. Then we saw children about the origin of electric charge. So as we had discussed that all the substances or objects, they are made up of very tiny particles, and these particles, they are made up of very tiny atoms. Now each atom, it has got a stationary positive charge and a moving negative charge. So each atom is electrically neutral. That means they are balanced. They have equal number of positive charge and equal number of negative charge. But when 2 objects, they are rubbed against each other, so what happens? The negative charge from one object moves to the other object. So the other object, it becomes excessively negatively charged, and the first object from which this negative charge had moved, that becomes positive charge, right children? So when 2 objects are rubbed against each other, one object becomes positively charged and the other object, it becomes negatively charged. Then we saw children about the frictional electricity, right? So the electric charge generated by friction is called as frictional electricity. Now this frictional electricity, it is actually for a short duration, right? So and this charge, it is produced only at the place of friction, and that is called as static electricity. So this charge, it is remains for a short duration, and these type of experiments you can carry only in dry weather, that is particularly in winter, because these charges of electric charge, they are absorbed in moist air, right? So this was what we had discussed in the session 1. So now let's move to the today's part. So we are still discussing about the frictional electricity, right? So this is the experiment wherein you can see here there is a straw in one hand, and the another straw, it is kept on a bottle. So now first what we are going to do children, we are going to keep just this straw on a bottle and another straw in the hand. So and when you bring this straw near the straw which is there in the hand, when you bring it near the straw which is kept on the bottle, what will you see? You can see there is no charge, because both are not rubbed against each other, or they are not rubbed and brought near each other, right? So there is no charge on the object, right? Now what will you do? The straw which is there in your hand, you will rub it against a woolen cloth. After rubbing against the woolen cloth, you will bring this straw near the straw which is kept on the bottle. Now you will see that what has happened. There is a now there is a charge, right? So there is attraction, right? They come near each other, that is they pull each other, so there is an attraction. Now what will you do? You will take both the straws, the straw which is kept in the bottle as well as in the hand, and then you will rub it against both the straws against the woolen cloth. And then after that, what will you do? The one straw you will keep it on the bottle, and the other straw you will keep it in your hand. And now you bring it near the straw which is kept on the bottle. What will you observe now? You will see that both are charged, right? So they will repel each other, that is they will push each other. So there will be repulsion in this case, right children? So what can we say? That electrically charged objects, they attract uncharged objects. So there is repulsion between the like electric charges, and there is attraction between the unlike electric charges. So repulsion, it is used as a test for identifying an electrically charged object. So as I told you children, when there are like electric charges, like positive positive or negative negative, then there will be repulsion. And when there is a positive charge and a negative charge, then there will be attraction, right? So as we discussed in the experiment, the first what happened, both the straws, when they were not charged, they were there was no charge on the object. But when one straw was charged and the other was uncharged, what happened? There was attraction, right? And then when we took both the straws which were charged, what happened? There was repulsion, right? So let's move to the next. Let's start with the next experiment. Now here what is there? You can see in the figure, water is flowing from the tap, and there is a comb which is brought near it, right? So this water which is flowing, this is called as thin trickle of water, means the water is flowing very slowly, right? So now what is done in this case? The water tap is open and you are taking a comb, right? So what you are going to do? You are going to take the comb and rub it on the hair, and you are going to bring it near this flowing water. So what will you see? That there is attraction. The water, it gets attracted to the comb. Now once you remove the comb, what will happen? Once you remove the comb, there will be no charge near the flowing water. So the water will flow as initially how it was flowing, right? So what we can conclude from this experiment children, that the comb which was charged, so for how much time you keep this comb near the flowing water, till that time that flowing water will be attracted towards the comb. Once you remove the charged comb from the flowing water, the water will come back to its original position. There will be no charge on that flowing water. So I hope students you have understood what is this generation of electric charge. So what is, when charged comb is brought close to the flowing water, water gets attracted, repelled, or remains as it was. So as I told you, when you bring the charged comb near the flowing water, what happens? Water, it gets attracted to it, right? So we will cut this. right? And when charged comb is taken away from the flowing water, water gets attracted, repelled, or remains as it was initially. So as I told you, when you are taking the charged comb away from the flowing water, water will get repelled, right? So this was about the generation of electric charge. Now, what happened? At first, the flow of water was not charged, as I told you. When the negatively charged comb comes near the flowing water, the negative particles in it nearest the combs, they are pushed away. So that part becomes positively charged due to the deficiency of the negative charge. So the comb, it has got negative charge, and the water, it has got positive charge. So that's the reason the water, it gets attracted to the comb, because they are opposite charge. Comb has got negative charge and water has got positive charge, so they are getting attracted. Then due to attraction between the opposite charges, the flowing water is attracted towards the comb. And when the comb, it is taken away, the negative particles in the flowing water come back to their original position, and the positive and the negative charge, they become equal in number. So water becomes uncharged again and stops getting attracted to the comb. So as I told you children, once you remove the charged comb, the water, it will become the attraction will stop and it will repel, right? So because what happens, the water, the charge which the water, it will become it will have equal number of protons, positive and negative charge, right? So now let's move to the next part. See here, now in the figure you can see a balloon. It has been sticking to the wall. Now why it is sticking to the wall? When you take this balloon and you rub it against a woolen cloth, so what happens, as I told you, that from the woolen cloth, the negatively charged particles, it moves to the balloon, right? So the balloon, it becomes excessively negatively charged, and that's why it gets stick to the wall which has got a positive charge, right? So what did we discuss about the balloon sticking to the ball? When the balloon, it is rubbed against the woolen cloth, what happens? The negatively charged particles from the woolen cloth, it comes to the balloon, and the balloon, it becomes excessively negatively charged. So the balloon has got negative charge and the wall, it has got positive charge. So that's the reason the balloon, it sticks to the wall. I'll discuss one more experiment with you children. If you take some thermocol or mustard seeds in a bottle, so what will happen now? And you shake this bottle, so you will see that the thermocol balls or the mustard seed, it will get stick to the bottle, right? But why does it get stick to the it gets stick to the plastic bottle, the mustard seeds and the thermocol? Because there is an attraction between the plastic bottle and the thermocol balls or the mustard seeds. Whereas if you see the thermocol balls and the mustard seeds, they will get repelled from each other, right? They will push each other away, but they will get attracted to the plastic bottle. Now this is one more experiment wherein this is the aluminium ball, and right, and this is a balloon with a negative charge. Now in this case what happens? The aluminium ball, it is uncharged, right? And what is happening in the first case, that is A, you bring a negatively charged balloon near the uncharged aluminium ball. So what will happen? There will be attraction. Can you see here? There will be attraction between these, because there are opposite type of charges, right? Now similarly in the second case B, right, you can see that both the objects, they are similarly charged, right? The aluminium ball, it is not charged, and the figure which is there in of the balloon, that is also not charged. So both are carrying similar charges, right? Now children, here you can see the figure. It is of the gold leaf electroscope, right? So this is an device. It is a simple device by which we can detect the electric charge on an object. So now you can see over here, these two are the gold leaves, right? They are two thin gold leaves, and this is a copper rod, right? And this is your metal disc, right? So, and this is a charged glass rod, right? And this you all know, it is a bottle, right? So what is done in this experiment, right? With this experiment, there is, as I told you, this is a copper rod. So the upper end of the copper rod, it is attached to a metal disc, and the lower end of the copper rod, to it there are attached two thin gold leaves, right? Now when you when this metal disc, it is uncharged, right? No charging has been done. So at that time what happens, the gold leaves which are there, it remains in the closed position, right? They come close to each other, they are in the closed position. But as you see, when a charged glass rod, this charged glass rod, when you are bringing it near the metal disc, what happens, the gold leaves, they open up, right? They repel from each other, that is, they push each other away, right? So when a charged glass rod, it is brought near the metal disc, the gold leaves, they repel from each other, they push each other away, or they open up, right? Now when you touch with your hand on the metal disc, what will happen, again the leaves, they will get collapsed. Collapse means they will come close to each other, and what will happen, so whatever charge is there on the leaves, it will go into the earth through our body, and the leaves, it will get discharged. That means the leaves, they will not have any charge, and that's the reason they will come back in the original position, that is the closed position. So I hope students, you have understood this gold leaf electroscope. Now let's see in detail. So gold leaf electroscope, this is a simple device to detect the electric charge on an object. So it consists of a copper rod which has a metal disc at the upper end and two thin gold leaves at the other end. The rod, it is placed in a bottle so that the disc is above the bottle. When an uncharged object is taken near the disc, the leaves remain closed. And when a charged object is taken near the disc, both the leaves are charged by the same electric charge, and they repel each other. That is, they move away from each other, or they open up. When we touch the disc with our hand, the leaves collapse. That means they come closer to each other, because the charge in the leaves, it goes into the earth through our body, and the leaves, it gets discharged. So children, I hope you have understood till this much. Now let's recap what we have learned today. So children, first we saw about experiments, right? So the first experiment was about the straw, right? So in the first experiment, we had seen that when we take the two straws which are uncharged, that time nothing happens, right? Then we saw that the one straw was charged and it was brought to the uncharged straw. So what happened? There was attraction, and when both of the straws were charged and they were brought near each other, there was repulsion. Then we saw about the one more experiment of taking a comb near the flowing water. So the comb, it was charged and it was brought to the flowing water. So what happened? The flowing water got attracted to the comb, right? So once the comb is removed from the flowing water, what happened? The flowing water also stopped the attraction, and it the water was flowing as it is, right? Then we saw about the experiment of the balloon stick to the wall, right? So what happened in that case also, because the balloon, it is negatively charged and the wall is positively charged, so the balloon, it gets stick to the wall. Then we took about the example of the aluminium ball and the thermocol balls and the glass rod. And lastly, we saw about the gold leaf electroscope. Now gold leaf electroscope, it's a simple device used to detect the electric charge on an object. So here also we saw the same thing. When you bring a charged object near the metal disc, the leaves, they open up, right? And when that charge object is taken away, what happens? And you touch the disc with your hand, what happens? The leaves, they come back to their original position, that is the closed position. So children, we'll meet in the next part. We'll meet in the next session with the next part. Till then, goodbye. So in the first experiment, we had seen that when we take the two straws which are uncharged, that time nothing happens, right? Then we saw that the one straw was charged and it was brought to the uncharged straw. So what happened? There was attraction, and when both of the straws were charged and they were brought near each other, there was repulsion. Then we saw about the one more experiment of taking a comb near the flowing water. So the comb, it was charged and it was brought to the flowing water. So what happened? The flowing water got attracted to the comb, right? So once the comb is removed from the flowing water, what happened? The flowing water also stopped the attraction, and it the water was flowing as it is, right? Then we saw about the experiment of the balloon stick to the wall, right? So what happened in that case also, because the balloon, it is negatively charged and the wall is positively charged, so the balloon, it gets stick to the wall. Then we took about the example of the aluminium ball and the thermocol balls and the glass rod. And lastly, we saw about the gold leaf electroscope. Now gold leaf electroscope, it's a simple device used to detect the electric charge on an object. So here also we saw the same thing. When you bring a charged object near the metal disc, the leaves, they open up, right? And when that charge object is taken away, what happens? And you touch the disc with your hand, what happens? The leaves, they come back to their original position, that is the closed position. So children, we'll meet in the next part. We'll meet in the next session with the next part. Till then, goodbye.